Welcome back. This class we are going to discuss about Gauss-Jordan elimination method for solving systems of linear equations. We begin by giving the steps we need to follow, and thereafter do an example to illustrate how the method works. So steps. So 1, write the augmented matrix of the system of linear equations. So the first step, write the augmented matrix of the system of linear equations given. Number 2, use elementary row operations to rewrite the system or to rewrite the matrix, augmented matrix into reduced row echelon form. Or you can start by writing into row echelon form, then reduced row echelon form. So once you have the row echelon form, then you reduce into reduced row echelon form. So once you have the row echelon form, you reduce it into row echelon form. And lastly, use back substitution. Reduce row echelon form, and find the solution. So let's demonstrate this on a problem. So e.g. solve the system. X1 minus 2x2 plus 3x3 equals to 9 minus x1 plus 3x2 equals to minus 4, 2x1 minus 5x2 plus 5x3 equals to 17. So here, the first thing is to fix these other unknown positions, this by 0x3, so that the augmented matrix would be 1, minus 2, 3, minus 1, 3, 0, 2, minus 5, 5, 9 minus 4, 17. And then, so this is what we call the augmented matrix. So next, change into row echelon form. So this being a 3 by 3 system, so we expect to have 1, 0, 1, 0, 0, 1. So we have this 1, minus 2, 3, 9, minus 1, 3, 0, minus 4, 2, minus 5, 5, 17. So the first position is in the correct form. So this is 1. So we make this 0 and this 0. So row 1 to be row 1. Row 2, we'll say row 2 plus row 1. And then row 3. Row 3 will be row 3 plus minus 2 row 1. So that will guarantee us to have a 0 at this position, a 0 at this position. So this will be 1 minus 2, 3, 9. So minus 1 plus 1 is 0. 3 plus minus 2 is 1. 0 plus 3 is 3. Minus 4 plus 9 is 5. And then we'll have 2 plus minus 2 times 1 is 0. Minus 5 plus minus 2 times minus 2 here, we get minus 5 plus 4, which is minus 1. 5 plus minus 2 times 3 is 5 minus 6, which is minus 1. $17 plus minus 2 times 9 is 17 minus 18. So this will give us negative 1. So we should be row 1 to be row 1, row 2 to be row 2, row 3, if we say row 3 plus row 2, this will give us 1 minus 2, 3, 9, 0, 1, 3, 5, 0, So this will be 0, this will be 2, and this will be 4. So the problem is these two. So we simply multiply by a half. So we have row 1 equals to row 1, row 2 equals to row 2, and then row 3 will be row 3 times a half. So which will be now, that step converts into the echelon form, because we'll have now 1 minus 2, 3, 9, 0, 1, 3, 5, 0, 0, 1, and then 2. So this is what we have row echelon form. Now, from row echelon form, we need now to have reduced row echelon form. So this is 1, this is 1, this is 1. So reduced row echelon form requires to have 1, 0, 0, 0, 1, 0, 0, 0, 1. So which means in this matrix, these two negative 2 is in the wrong position. So I correct these two by using this second row. So I say row 1 to be row 1 plus twice row 2. And then row 2, let me keep it as row 2, and row 3, at this stage, let me keep it as row 3. So this will give me 1 minus, okay, so minus 2 plus 2 times 1 is 0. So this will be 0. 3 plus 2, 3 plus 2 times 3. So that will give me 9. So I put here 9. Then 9 plus 2 times 5 will give me 19. So this is 0, 1, 3, 5, 0, 0, 1, 2. So by doing that, I've successfully converted this second column into the correct form. So the problem now is at this position and this position here. So I correct this position of 3 and this position of 9 by row 3. So I say row 1 to be row 1 plus minus 9 row 3, row 2 to be row 2 plus minus 3 row 3, and row 3 to remain to be row 3. So here, I'll get 1, 0 minus 9 times 0 is 0. 9 plus minus 9 times 1 is 0. Now 19 plus minus 9 times 2 is 19 times 19 plus minus 18. So 19 minus 18 is 1. So I get this position to be 1. So 0, here will be 0, here will be 1. Then 3 plus minus 3 times 1 is 0. Now 5 plus minus 3 times 2 is 5 minus 6, which is minus 1. And then here I have 0, 0, 1, 2. So then this is the reduced row echelon form. So I have x, our variables were x, x1, x2, x3. So I'll have x1. So this is the reduced row echelon form. X1 equals to 1, x2 equals negative 1, and x3 equals to 2. So those are the solutions. So therefore, x1 equals to 1, x2 equals negative 1, and x3 equals to 2. So for the case of Gauss-Jordan elimination method, you simply get the solution for the variables just in one way, unlike in the case of Gaussian elimination where you have to do back substitution. This one you get the answers directly once you have the augmented matrix put into reduced row echelon form structure. So those are the solutions to that given system. Thank you.